So this is question 8 of KA4 for maths. We've got some trig. So first bit, show that 5 cos theta is 24 tan theta, can be written as that. Now there's only one thing we can do at this point, and that is swap the tan for sine over cos. Now, I don't like that fraction, so I'm going to times through by cos straight away. So I get 5 cos squared is 24 sine. Now, there's two ways we can spot this. Either we know we're after a sine squared in the end and we've got a cos squared, or we need to make the squared term, we need to make this match the non-squared term. So the only way we can do that is by using, let's write that back in, using the trig identity, cos squared plus sine squared is 1. So cos squared is 1 minus sine squared. So we've got 5, 1 minus sine squared equals 24 sine. So we've got 5 minus 5 sine squared theta is 24 sine. Moving it all to one side will give us the required result, minus 5. Now, part B we could have a go at even without having done part A, because it's just using the same thing. This is this. So just use it. And this is much more standard. So first, we've got to solve this quadratic for sine. Now, loads of ways you could go about this. You could keep it in sine. That would be fine. But a lot of you will find it easier to spot the roots, to factorise it, if we swap sine for something else. Now, I would always go for something like s. Never go for x, y, theta, because they're already being used a lot. So let's avoid them. Although s is a dodgy choice for this, for me, because of the 5s. Maybe something, let's go for s. So we've got 0 is 5 s squared plus 24 s minus 5. We can factorise that. 5s, what's it going to be? Plus 5 minus 1. So we've got s, let's jump a line. S is 1 over 5, or s is minus 5. So sine theta is a fifth, or sine theta is minus 5. Now this is less than minus 1, so no solutions there. Remember, sine's got this max at 1 and min at minus 1. That's an awful sine graph, but gets the point. So now we go into our calculator. I can't display my calculator on here, but I can say we go into graph. So y1 wants to be sine x, y2 wants to be a fifth, and our view window wants to have x min as minus 180 and x max as 540. You wouldn't need to write all this. You don't need to write that. You would just write the x values that come out. So let me quickly whack that in. So we go to graph. y1 is sine x. Oh, do also make sure you're in degrees as well. View window, minus 180, 540. G-solve, intersect. So you get 11.5. Oh, what's the degree of accuracy it wants? 1 dp. 11.5. 168.4. 371.5 and 528.4. Okay. So part C needs you to be quite aware of the graph. So we've got deduced number of solutions to the interval when we've got 8x in there now instead. Now that's going to multiply our interval by 8. So the easy way is to go 8 times 1, 2, 3, 4, going to be 32. A different approach would be to just plot it. If you plotted the extra interval with 8 times the range and counted how many solutions would be, you get 32. But yeah.